Welcome. In this presentation, we'll dissect a common and critical enterprise scenario, establishing a high-performance, flexible, and secure connection from an on-premises data center to Google Cloud. The question presented gives us a very specific set of requirements that we must satisfy. This isn't just about basic connectivity. It's about building a robust bridge that meets stringent demands for speed, administrative control, and secure access to Google's powerful suite of services. Let's look at the question on the slide and break down each requirement piece by piece to understand its implications for our architectural choices. Deconstructing the requirements. Let's translate these business needs into technical components. Each requirement points directly to a specific Google Cloud service. First, the 20 gigabits per second high throughput requirement points directly to the Cloud Interconnect family of products, as this level of bandwidth demands a physical, dedicated connection. Second, the need to change IP ranges on our own demands a dynamic routing protocol like BGP, which is provided by Cloud Router. Third, the ability to privately access Google Cloud products via their public IPs is the specific function of private Google access for on-premises hosts. Choosing the right physical connection. The first decision is the physical link. It is vital to understand the difference between Cloud Interconnect and Cloud Peering. Cloud Interconnect is the correct choice for this problem. Its purpose is to extend your on-premises network to your private VPC network, allowing on-prem systems and GCP VMs to communicate using private IP addresses. This is an extension of your private network. In contrast, Cloud Peering is for a different use case. Peering allows you to exchange traffic with Google's public network. It's for companies that want a more direct, reliable path to Google's public services like search or YouTube. It does not provide access to your private VPCs. Since our goal is a hybrid environment connecting our on-prem network to our cloud network, we must use Cloud Interconnect. This immediately eliminates the options involving direct peering or carrier peering. The difference: dedicated versus partner interconnect. Now that we've established we need Cloud Interconnect, we have two options: dedicated or partner. Dedicated interconnect is the premium choice. You provision a direct, physical cross-connect from your equipment to Google's equipment in a shared co-location facility. It offers the highest speeds, 10 gigabits per second or 100 gigabits per second circuits, and gives you full control. To get 20 gigabits per second, you would provision two 10 gigabits per second circuits, which perfectly matches our high throughput requirement. Partner Interconnect provides more flexibility by connecting to Google through a supported service provider. This is often faster to provision and offers a wider range of connection speeds from 50 megabits per second to 50 gigabits per second. While a 20 gigabits per second connection is possible, dedicated interconnect is the most direct and high-performance way to achieve our goal, making it the strongest candidate. Choosing the right access service. This is another common point of confusion. The question requires access to Google Cloud products, like APIs, which live on public IPs. The options mention two services: private Google access for on-premises hosts, and private service access. Private Google access for on-premises hosts is the correct service for our use case. When you enable this, Google configures special DNS and routing. When your on-prem host tries to reach a Google API, the request is routed over your private interconnect link to a set of private virtual IPs that Google manages. Your traffic never touches the public internet. Private service access is used for a different purpose. It allows your VPC to connect to a Google-managed service that has its own VPC, like a Cloud SQL instance. This is for VPC to Google service VPC communication, not on-prem to Google API communication. Therefore, any option that includes private service access is incorrect for solving this problem. Putting it all together, the correct solution. Let's re-evaluate the requirements with our newfound knowledge. The 20 gigabits per second throughput points to dedicated interconnect. The need for dynamic IP range changes requires Cloud Router. The requirement for private access to public Google APIs is the exact use case for private Google access for on-premises hosts. Analyzing the options, we can see why only one is correct. The first and third options fail because they incorrectly list private service access. The second option fails because it lists direct peering, which is the wrong connection type for accessing a private VPC. This leaves only the fourth option, which correctly combines dedicated interconnect, cloud router, and private Google access for on-premises hosts. Final architecture review. Let's visualize the final, correct architecture. Your on-premises data center has a router. You've provisioned two 10 gigabits per second dedicated interconnect circuits to a Google Cloud point of presence. Inside Google Cloud, these circuits terminate as VLAN attachments. A cloud router is associated with these attachments. This cloud router establishes a BGP session with your on-prem router, dynamically exchanging routes in both directions. Your on-prem network learns the routes to your VPC subnets, and your VPC learns the routes to your on-prem subnets. When an on-prem server needs to access cloud storage, it makes a request. Thanks to private Google access, this request is routed over the private interconnect link to Google's internal network, and then to the cloud storage service, completely avoiding the public internet. This architecture is secure, fast, and resilient.